once again. Today I want to take you through the topics which you must read before you enter a chemistry paper 2 exam, Kcse exam. So these are the topics that are a sure bet that you must expect. In fact, they will not miss. Therefore, even before you go to an exam room, you must know the topics that are there. Therefore, I'm giving you this topic that I consider the most common topics that you will expect during a paper 2 exam in chemistry. The first topic is organic 1 and organic 2. Organic 1 deals with the hydrocarbons, the compounds with hydrogen and carbon only, and then organic 2 combines both carbon, oxygen, and hydrogen. So you must ensure that you have read, you have gone through all the questions that concern the flowcharts of the organic chemistry. You know the double bond, the triple bond, and the single bond. You know the organic acids, the alcohols. Those are the things you must understand. So that one is a sure bet. It will be there. It will never miss. Question number 2 is metals. A metal cannot miss an exam because actually students don't like reading the metals. Therefore, metals is repeated each year. Every year, metals are there. What about electrochemistry? Electrochemistry is another topic which will always be there. Electrolysis, the electrochemical cells, that one will not miss. Therefore, these are the marks. In fact, paper 2 is the cheapest paper that every student should get at least 60 out of 80 because you know the topics. These are the topics. It can even take around 5 hours. You read them, you do them, and then you will score, you will change your grade in chemistry. The next one is salts. This we have a flow chart for salts, so you should also read for salts in form 2. You should understand salts, effect of heat on salts, carbonates, all those things you must know them. Another question that you must expect is the processes that are used to manufacture different gases, different acids. The HAPA process is used in the manufacture of ammonia gas. So you should know the raw materials, the impurities which are removed in the HAPA process, the raw materials, the impurities, the catalyst that is used in the HAPA process. Those are the things you must read and get them right. You should know the reaction in the catalytic chamber. You should see that process coming and you should have it in your fingertips in short. The next one is the sulfate process in form 2 where we manufacture sodium carbonate. So that one you should also have it in your fingertips if you really want to score marks in paper 2. Another process that you must know is the contact process. The contact process is the industrial manufacture of sulfuric 6 acid. So in sulfuric acid, you must know the raw materials, the catalyst used in the contact process, the why impurities are removed, the reaction in the catalytic chamber. You should know all of those things. Oleum, the reaction where oleum is taking place, why sulfur 6 oxide is not directly dissolved in water. It is first dissolved in sulfuric acid and then diluted later in the dilution chamber. So those are the things you must know before you go to an exam room paper 2. And also you should know the reason why the sulfur 4 oxide is not allowed to go to the atmosphere. What process is that is used to prevent sulfur 4 oxide into the atmosphere? Scrapping. You must know what is scrapping. How is the equation of scrapping written? Those are the things you must know. Another process that you must know before you go is the Ostwald process. The Ostwald process is the industrial manufacture of nitric acid. So with the upper process to give you one flow chart. Therefore, you should know that. Another free 10 to 12 marks is the periodic table. That one is a sure bet. You should be sure of this. There is no day exam has been set and there is no questions of the periodic table. Periodic table involves the questions in topic 1 in form 2, the structure of the atom, topic 2, which is the chemical families, and topic 3, which is the structure and bonding. Therefore, these 3 topics form the periodic table actually. Therefore, you must expect 12 marks or 10 for the
In the next segment, my dad will bring you random questions in chemistry paper 2. Remember to share and like.
Success in your exam tomorrow paper 2.
Success in your exam.
The grid below is part of the periodic table. Use it to answer the questions that follow. The letters do not represent the actual symbols of the element. So that's the question. You always find that. Now this is a simple periodic table that as you can see it. So for you to answer the questions in the periodic table, you must master the periodic table. You must now this, for example, this. So this periodic table, simple periodic table, you should know that this one, the first square here is atomic number 1. So you should first write those atomic number. Write them atomic number 2, atomic number 3. So because you cannot answer these questions unless you know the atomic numbers. So this is atomic number 4, atomic number 5, like that up to the end. So once you have written the atomic numbers from 1 up to 20, now you will be able to know what you are doing. Remember, the first square is for hydrogen, the second square there is for helium, and then beryllium, lithium, boron, and then we go to carbon, like that, nitrogen, all the way to calcium, atomic number 20. So once you know that, you should know these elements represented by Z, what they are called. So let us go to the question and see what they are asking. Indicate on the grid the position of an element represented by a letter V whose atomic number is 14. An element number which is atomic number 14, therefore you should be able to count from here 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, and 14. So 14 is here. It means that this element is supposed to be there. So this is the element which is atomic number 14. Because if you don't know how to count this one is going to be difficult for you to give it. So we have answered that. Next question is select a letter which represent a monoatomic gas. A monoatomic. We have diatomic gases like hydrogen is a diatomic, oxygen is a diatomic, chlorine is a diatomic. But we have group 8 gases, they are monoatomic. That is neon, helium, they are monoatomic. So in this case, U is a monoatomic gas. In this case, we have U, they have atomic gas. Because group 8 gases, group 8 elements, most of them are gases. Helium is a gas, argon is a gas, and argon is just written Ag. Argon is Ag. AR, a small r. So you can see they don't have the two like we have in chlorine or in oxygen. They are just monoatomic. Mono means one atom. Yes, monatomic. Write an equation for the reaction between Q and T. So before you write, go to Q and T. What is element Q? You should know that this is element, this element, and that element. So Q, this is atomic. You count 1, 2, 3, 4, 5, 6, 7, 8. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So Q is atomic number 12, right? Q is atomic number 12. So if Q is atomic number 12, that's magnesium specifically, and then T is chlorine, that is atomic number 17. Therefore, Q is magnesium. So Q is, I think this one is right. This this answer somebody used aluminium. It should be magnesium because Q is atomic number 12. So write an equation. So the equation you can write either using the letters provided, or you can use the real element. So this one should be magnesium. 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 I don't think this one is going to be there. Plus chlorine, which is going to give us magnesium. Magnesium chloride, and this one should be 2. Should be 2. So magnesium chloride, and this is the chemical, the equation for the reaction. Because you have been asking the equation, you included the status. Magnesium is a solid, chlorine is a gas, magnesium chloride is a solid. This one now we can change this one. You can remove this Q and remove this like this, and then remove this like this, and then you put 2 here. If you want to use those letters, then you make sure you do like that. Now this one is, you have written the equation the way it is expected, then ensure you write the status. So the most important is to understand the periodic table. Whenever you must know that the first one is hydrogen, and that is atomic number 1, then you write the atomic numbers. That will, so by now you should know that U is atomic number 18 and P is atomic number 19. Explain why N and Q would not be expected to form a compound. N and Q. N is a metal. Actually, it is sodium. Q is another metal. Actually, that one is magnesium, we have said. There is no way a metal and a metal can react. So that one we should know. Therefore, we don't expect a compound there because they are both metals and need to lose electrons. So there's none of them will gain electrons. Therefore, they need to lose. Therefore, they will not react because they are both metals. To which period and the group of the periodic table does element Q belong? Q. So for you to know the period and the group where Q belong, you must write the electron arrangement, electron configuration of Q. For example, Q, it is atomic number 12, we have said, so therefore it is 8, 2.8.2, right? So once we have written the electron configuration, now you can be able to group this element. That tells us that the outermost energy level, there are 2 electrons there, it means it is group 2. It has how many electrons, many energy levels? 1, 2, 3. Therefore, it is period 3. So Q is the electron configuration is written here, right? And then it is group 2 because it has 2 electrons in the outermost energy levels. So it is in group 2. It has 2 electrons in the outermost energy level. And a period 3 because it has 3 energy levels. How do you know it has 3 energy levels? You count. The first one is, the first energy level is 2. The second energy level has 8. The third has 2. So the total is 12. So that's how you know. So for you to know the group of an element, the period of an element, you must write the electron configuration of that element. For you to write the electron configuration of that element correctly, you must know the atomic number of that element. How does the atomic radius of N compare with that of Q, the atomic radius? Explain. So let us go to N and Q, see the relationship between them. N and Q. N and Q across the period. You can see N is 11 and Q is 12. So what is the relationship? What happens across the period? What happens to the atomic radius across the period? So those are the things we run. So you should know that across the period, the atomic radius decreases. Mark that. Across the period, the atomic radius decreases because of the increase in the number of protons, right? As the number of protons increases, because across the period the atomic number is increasing. This is 11, 12, 13, 14, 15, 17, 15, 16, 17, 18. So across the period, period 3, that is, the atomic number is increasing, the number of protons are increasing. So therefore, across the period, there is an increase in the nuclear charge. Remember, the nuclear charge is the force that is holding the electrons in the outermost energy level. So if the nuclear charge is increasing, it means the outermost energy level are strongly held towards the center, towards the nucleus. Therefore, the atomic radius decreases because the outermost energy levels in U are strongly held by the nucleus, because across the period the nuclear charge is increasing because the protons are increasing. Remember, the protons are found in the nucleus. Therefore, how does the atomic radius of N compare? So we can say that Q has a smaller atomic radius than N. Q has a small atomic radius than N. That is very correct. So we can say that, is it, which one we are comparing? Sorry. Oh, this one is for P. I think I've answered a different question, but it's okay. We are talking about N, I think it is this one. P, how does the P and N? I think there is a... So we have answered this. How does the atomic radius of N compare with that of Q? We have said that N and Q is across the period. Therefore, the answer is Q has a small atomic radius compared to N. That is correct. Q has a small atomic radius compared to N. This is because Q has more protons. So the nuclear charge is higher, hence attract outermost electrons more strongly. So you should know that across the period, the atomic radius decreases. Why? The number of protons increases, therefore the nuclear charge increases. The responsibility of the nuclear charge is to attract the outermost energy levels. So if the number of protons increases, the nuclear charge increases, and it holds the outermost energy levels strongly as you move across the period. Very correct. The next question of a similar is, how does the atomic radius of N compare with that of P? So that one was across the period. What about down the group? How does the atomic radius of N and P compare, these two? Which one has higher atomic radius and a smaller atomic radius? So P has a larger atomic radius compared to N, because down the group there is an increase in the number of energy levels. Therefore, atomic radius increases. Atomic radius increases. Larger atomic radius compared to N, P has more number of energy levels. Since down the group, atomic number increases. Therefore, down the group, the number of energy levels increases. Therefore, the atomic radius will always increase down the group. What type of bond would be present in a compound formed between T and Q? Explain. So you go to the periodic table and check between Q and T. So Q is a metal. T is chlorine and an metal. So the bond between a metal and an metal is ionic bond. In ionic bonding, there is complete transfer of electrons. Therefore, the bond between Q and T is ionic bond. Here, this is a bond between a metal and an metal. Therefore, there is complete transfer of electrons from one element to another. And you have explained, you expect your 2 marks. The answer is ionic bond. Remember, the bond between an metal and an metal, like oxygen and carbon, it is a covalent bond. Except for carbon 2. Carbon 2, we have dative bonding. You should know that. Thank you. What name is given to a group of elements to which S and T belong? Another way of asking this question is that what is the name of the chemical family to which S and T belong? So let us go to the table and check S and T, which, so we have S and T. So S, so we can now see this is group 1, group 2, 3, 4, 5, 6, 7. So S and T are found in group 7. What is the chemical family given to group 7 elements? This one is called halogens. You should know that. So group 7, S and T belong to a chemical family called halogens. Group 1, we call it alkali metals. The group 1 metals are given the name alkali metals. Group 2, this one, group 2, they are given alkaline earth metals. Group 2 elements are called, the chemical family or the chemical name for group 2 is called alkaline earth metals. Make the difference between group 1 and group 2. People confuse a lot between group 1 and group 2. Group 1, they are called alkali metals. Group 2, they are called alkaline earth metals. Group 7, they are called halogens. So you write that group 7, these are called group 7 and they are called halogens. They are just called halogens. Therefore, that is the chemical name for group 7 elements, halogens. Give the name to element Z. So element Z. These are elements which are not in the small periodic table. We call them transition metals or transition elements. Don't call them transitional. They are not transitional, but if you write transitional, be sure that you will get it wrong. It is called, this element Z, they are called transition elements. Transition elements. Elements or metals, so it's accepted. Element U is generally unreactive. Explain. Which one is that element U? You come to the periodic table. Element U is found in group 8. This is group 8. Group 8 elements don't react. Why? They are stable. They neither lose electrons nor gain electrons. They don't gain, they don't lose. Therefore, they are stable. Why are they generally unreactive? It is because they neither gain electrons nor lose electrons. Therefore, they are stable, they don't react. Element U neither gains nor lose electrons because it is stable, hence unreactive. Using dot and a cross to represent outermost electrons, draw a diagram to show the bonding in the compound formed when M and R react. You must know. So let us count 1, 2, 3, 4, 5, 6. 6 is carbon. 7, 8. AR is oxygen. So this is the compound that is carbon plus oxygen. You should know that carbon plus oxygen, this is an metal, therefore the bond is covalent. Therefore you should know how to draw a covalent structure where they are going to share electrons. I may not draw now, but you should know how to draw. But I have done that in my video which is there in the YouTube. So this is the kind of question you need to expect in paper 2. This is the question which you will not miss there. So make sure you go through the revision of the periodic table. Make sure you know. Another thing you must know is to compare the atomic radius and the ionic radius. For example, you can be asked, how will you compare the atomic radius of N, the atomic and ionic radius of N? So you should tell us that the ionic radius of N is either smaller or bigger, and therefore you should know those things. How does the ionic and atomic radius of Q compare? Explain. If it is halogens, how does the atomic radius and ionic radius of T compare? You should know that. Down to a group of halogens, which one is the most reactive and which one is the least reactive? How does the ionization energy of the halogens compare down to a group? How does the ionization energy across period 3 compare? Therefore, those are the things you must learn and be aware as you prepare for your exams. Therefore, I give the systematic names for the following compounds. You have been given the first compound here. You need to look at it and then identify which type of compound is this. You look at this from C to here. You can see the functional group is RCOOH. So that tells you this is an alkanoic acid. The next thing, after identifying that this is an alkanoic acid, then you count the number of carbon atoms, 1, 2, 3. That tells you that this is propanoic. Propanoic acid. That tells you that one is propanoic acid. The next compound, you look at this, and whenever you see CH and there is double O, excuse me, double O in between, then you should know that one is an ester. The process of forming this one is esterification, where an alcohol is reacting with an alkanoic acid, in the presence of concentrated sulfuric acid. So this compound here is this. We start from here, 1, 2, ethyl. This is ethyl. Ethanoate, 1, 2, ethanoate. So the alkyl part comes from the alcohol and the alkanoate part comes from the acid. Then the last one, the number 3, here when you look at this one, you may not tell exactly what it is. So we don't know whether this is an alkane, an alkene, or an alkyne. What you do, count the number of carbon atoms, 1, 2, 3, 4. Write the structural formula for that compound. Once you have done that, so put the hydrogen. That's the first carbon has got 1 hydrogen. The second one does not have any hydrogen. The third one has got 2. The fourth one has got 3. Now you are aware that each carbon atom must be surrounded with the 4 covalent bonds. So look at this one, 1, 2, 3, 4, it's okay. 1, 2, 3, it's okay, 4. And look at this carbon number 1 and number 2, 1. This one has got only 1, 2. What about this one? This one has got 1, 2. So what is missing? If you put a double bond, another dash here, a covalent bond, still this one will be 1, 2, 3, 1, 2, 3. So it means you had another one again. So we will have 1, 2, 3, 4, 1, 2, 3, 4. Therefore, this compound is an alkyl, I don't know, alkenes, alkynes. It is an alkyne. Triple bond means it's an alkyne. Therefore, this one is now the double bond. The functional group is in carbon number 1. Therefore, we say but 1 ine, and that is the systematic name for that compound. The scheme below shows a series of reactions starting with ethanol. Study it and answer the questions that follow. So before you go to the question, you are supposed to analyze this chart, this flow chart properly, because you have read the concept, the content. Now look at this. We are starting with the ethanol. What does ethanol undergo to form ethanoic acid? This is ethanol. This is ethanoic acid 1,2, ethanoic. Therefore, this one is oxidation. So step 2 is oxidation. What are the reagents that are used in oxidation? We know we use acidified potassium permanganate or 7 or acidified potassium dichromate. Those are the that we have talked about. Now let's go to step 2, step 3 here. Step 3, what's happening? Ethanol 1,2 ethanol is undergoing a certain step, forming 1,2, forming ethene. This is ethene. So which step is this? Step 3 is dehydration. Dehydration is the removal of water from a compound. So what has been taken away? This OH has been taken away to remain with the ethene here. So we have ethene, dehydration. The conditions necessary for the dehydration to occur is conc sulfuric acid. Conc sulfuric acid. Step 4. Step 4, ethene 1,2, ethene is undergoing a step 4 to form a polymer. This is K is a polymer. It must be a polymer. It is a polymer. Then we will know, of course, this is ethene. This is going to be polyethene. So the polymer here is polyethene. So K is polyethene. That one is obvious. Now let's go to step 1. This one, this is ethanoic acid. Ethanoic acid is reacting with magnesium. It reacts with magnesium to form products here. So this is an acid, remember? An acid plus a metal is going to form a salt plus hydrogen gas. So the product here is going to form magnesium ethanoate, magnesium ethanoate, magnesium ethanoate plus hydrogen gas. Those are the products. But when ethanol is reacting with magnesium or a metal, any metal, it forms magnesium ethoxide. Ethoxide plus hydrogen gas. So that is the difference. Ethanol will react with the magnesium to form a salt called magnesium ethoxide, while ethanoic acid will react with magnesium to form magnesium ethanoate. So that is the difference. Now, step here, the ethanoic acid is reacting with sodium hydroxide to form sodium ethanoate. This one is sodium ethanoate. Sodium ethanoate is undergoing step 4 to form methane. This is methane. Methane is undergoing the process here in excess chlorine to form compound Z. So which step this process here where we use UV light is called substitution. Substitution, because we know alkanes does not undergo many reactions other than combustion and substitution, because alkanes are saturated are saturated, therefore they don't have much reactions. So we are going to see compound Z. Compound Z is we are going to form excess. If it is excess, we are going to form CCl4 tetrachloromethane. We are going to form tetrachloromethane here. Then we have when this one is heated, methanol. We are using methanol and ethanoic acid. Ethanoic acid, not ethanoic, but ethanoic acid, yes, plus methanol. This is an alkanoic acid plus an alcohol. That process is esterification. We are going to form an ester, because in the presence of sulfuric acid, we are going to form an ester, and water is formed. So what will be the name? Because the acid, the alcohol is methanol, so we are going to form methyl ethanoate. This one is going to X is methyl ethanoate. Methyl ethanoate, which we will write CH3 COOCH3. This is an ester called methyl ethanoate. So ukishachambua namna hiyo, now you can go to the questions and try to see what the question required you to do. Name the type of reactions, and the conditions in step 2. So step 2, so we have said step 2. Step 2 here is oxidation. The conditions there, we need heat, that is temperature. Yes, so that one is oxidation. The condition is you warm. The reagents, now that is the reagents that we need. You can use acidified potassium permanganate. This H refers is for acidified, or you can use acidified potassium dichromate stroke so any of this one can work best. Step 3, type of reaction taking place in step 3. So we go back to step 3 and look at that. Step 3 is dehydration. The conditions necessary is sulfuric acid. So you see, you have done already finished. You are just copying what you have done. This one is dehydration. Reagent is sulfuric acid. You can simply write sulfuric acid, but you are told name the types of reactions. Name. So you are asked to give the name. Please don't write the chemical. So like here, it is important you write acidified potassium permanganate 7, because that is the name. That is here. They consider that because they say the name. If they said identify, you can write another thing. But for the name, here write, this is warming. Here you write acidified potassium manganate 7. So here is sulfuric acid. It is important you know that whenever you are asked to give the name, it should be the name and not the chemical symbols. So this one is conch, sulfuric acid. So the condition, we need a temperature of 160 to 180 degrees Celsius. Whenever you ask it to name, give the name and not otherwise. Write the equation for the reaction taking place in step 1. Step 1. So we can look at the reaction in step 1. So what is in step 1 there? Step 1 is ethanoic. So step 1 is ethanoic reacting with magnesium to form magnesium ethanoate. So this one is simply CH3 CCC So that is the equation that you are required to write. Name the product X. X is methyl ethanoate. We said that is the ester. Methyl ethanoate. Identify the process leading to the formation of compound Z. Compound C, actually that was substitution. So we say the compound Z. This is where we had compound Z from, that is substitution. We said here is the substitution, and that is the process of forming compound C. And the compound C, because they are using excess chlorine, then it is going to form tetramethane tetrachloromethane. Identify the process. The process is substitution. Name compound K and state one of its uses. Compound K is a polymer, and we say that polymer is polyethylene. So what are the uses of polyethylene? Uses of polyethylene. So name the polymer is polyethylene. Uses are many. Used in the manufacture of plastics, pipes, manufacture of paper bags, plastic bags, used in the manufacture of insulators, and many others uses. The so that is 12 carbon. One carbon is 12. There are 2 of them. Then plus hydrogen, there are 4 times 1. So we will have everything 2 times n. This is 24 plus 4, so we have 28 n will be equal to the total mass. which is 39, 200. So 28N is equal to 39, 200. You divide by both sides by 28, divide by both sides by 28, so N will be 1400. So there will be, in this compound which contains this mass, there will be 1400 monomers that will form this polymer here. Name of the compounds that are shown below here. So which compound is this? First count the number of carbon atoms. Here we have 1, 2, 3, 4. So we have 4 carbon atoms. We have 4 carbon atoms. Now that one can be an alkane, an alkene, an alkyne, and alcohol or alkanoic acid. So what will tell you that what type of this one? You look at the functional group, what we call the functional group. So the functional group here is OH, and the OH is an alcohol. So if these are alcohol, then which name that is given for an alcohol with 4 carbons? Definitely it is going to be butanol, right? Butanol. So butanol is the alcohol, but is that the name? No. Look at where the functional group is. The functional group is on carbon number 1. Therefore, the correct name is butan 1-ol. So butan 1-ol is the correct perfect name for you to score the marks. Look at the compound number Roman 2 is given as COOH. So which compound is this? These are alkanoic acids. These are alkanoic acids. Then look at carbon numbers 1, 2, 3. These are 3 carbon atoms. So if there are 3, then that one should be 1, 2, 3. Therefore, remember the ethanoic acid, butanoic, propanoic. Therefore, this one is propanoic because 3 is propanoic. Then look at the next one, Roman 3. Which compound is this? When you see this compound written in this way, you should know that this one is an ester. You should know that this one is an ester. So esterification, the process is esterification. So which ester is this? Look at this is 1, 2. So the alcohol from which they combined with alkanoic acid, ethanoic acid is 1, 2. So this one is going to be, the name is going to be ethyl. It's called ethyl. Ethanoate. This is the process, is esterification. You need to know that. Describe a chemical test that could be used to distinguish between Roman 1 and Roman 2. So how can you distinguish? How can you differentiate between an alcohol and an alkanoic acid? How can you distinguish that? So describe a chemical test that can be used to distinguish between substance 1 and substance 2. Substance 1 is butanol and propanoic acid. So put the ethanol and put the alcohol and the alkanoic acid in separate test tubes. Add a spatula of sodium carbonate or sodium hydrogen carbonate to each of them. So effervescence will be produced or will occur in the test tube containing the CH, the alcohol, the alkanoic acid. Where the test tube with alkanoic acid, effervescence will occur. And the test tube which containing an alcohol, no effervescence will occur. And that will be able, will help us to differentiate that this one is an alcohol and this one is an alkanoic acid. So in alkanoic acids, effervescence is produced when you add sodium carbonate or sodium hydrogen carbonate. But a test tube containing an alcohol like butanoic acid, like butanol, there is no effervescence. In butane 1 all, there is no effervescence. Study the information in the table below. Number of carbon atoms per molecule, relative molecular mass. Write the general formula for the hydrocarbon. In the table. So the general, we have been asked you to write the general formula, but look at here. So how will you tell that this is the general formula? Tumepewa kuna number 1 iko na carbon mbili. So carbon mbili, each carbon inakuanga na 12. So that is 24. Sawa? But the total mass is 28. So 20 ukitoa hiyo itabaki 28 minus 24 itabaki 4. So inamaanisha the hydrogen there are only 4 of them. So which element, which organic compound will be that? Will it be an alkane, an alkyne, or an alkene? So check. So if we put C2 here, then H4. That's what we have. Carbon ni mbili, hydrogen. So carbon 12 times 2 is 24. So inakuwa the mass ya carbon peke yake ni 24, lakini total mass ni 28. So yenye mebaki ni hydrogen na ni 4. Kwa hivyo this one. So which one is this? Unaona hiyo, like this one is ethene, which is C double bond C and then H. That is it. So the general point, the general formula for alkenes is CnH2n, and that is it. So we have known that these are alkenes. You can even do with the third one and confirm. Predict the relative molecular mass of the hydrocarbon with 5 carbon atoms. So 5 carbon atoms, you simply write C5H 2 times 5 from the formula. That one will give us C5H10. You just use the formula you have created there, and you will tell us that the second one is this. So we have been asked to predict the molecular mass. So carbon, if this is the form, the compound, then carbon, 1 carbon is 12 times 5 plus hydrogen times 1. So this one is going to be 60 plus 10, and that one will be 70. The molecular mass for the 50 carbon will be 70. Determine the molecular formula of the hydrocarbon for this one and draw the structural formula. So we will determine that. So that one is C5H10, and the structural formula is 1, 2, 3, 4, 5. And we put a double bond there. Here we will have hydrogen. There we will have hydrogen. 1, 2, 3, 4. Here we will have 1 hydrogen. This is the structural formula for pentene. And that is it. That is the structural formula for that. That is the structural formula for that one. Study the scheme below and answer the questions that follow. So when you are given this one, you need to, you can see this is alkyne. So 1, 2, this is actually ethyne. This is ethyne. So ethyne will undergo step 1 to form. You can see this one is ethane. So ethane has been formed from sodium ethanoate. So from sodium ethanoate, this is a laboratory preparation of alkanes. So the conditions that we need here, we need soda lime, which we call sodium hydroxide. So that's what the condition necessary for a ethane to move or to react to form ethane. The process is hydrogenation, addition of hydrogen. So here we need hydrogen, and then the conditions that we need there is the catalyst, nickel catalyst, and the temperature of between 150 and 250. So that is for step 1. Then step complete combustion. So when organic compounds undergo combustion, we know what they form. So if this one is going combustion, is going to form carbon 4 plus water. Then we have ethane to step 2. It is going to form 1, 2, there is a Cl here. So it means there's an addition of HCl. There's an addition of hydrogen chloride gas. So this one will undergo a certain process, step 3, to form this. What is this? This is a polymer. So the process here is polymerization. Now, before even you go to the questions, you need to analyze the diagram like that, and then you are able to answer the question. Name the reagents used in step 1. Step 1, we need hydrogen. So in fact, excess hydrogen will take us to alkene and then alkyne. Step 2, which is condition we need hydrogen chloride. We need hydrogen chloride gas for step 2 to occur. Step 4, what reagent? So here we have not asked the conditions. The next question now we repeat the conditions. What are the conditions for step 1 to occur? What are the conditions for step 2 to occur? Now, I already have said for hydrogenation we need nickel catalyst and a temperature of 150 to 250. So that one here, this question has not asked that, but it is important you know. Hydrogenation, step 4. Which one is step 4? Step 4, that is the formation of alkanes in the lab. Laboratory preparation of alkanes. We need the soda lime, and that soda lime is sodium hydroxide. Explain one disadvantage of continued. Before that, write an equation for the complete combustion of this. So this one is C2H2 plus oxygen. So this one is going to form carbon dioxide. An organic compound undergo combustion to form carbon dioxide plus water. So we need to balance this equation. We have 2 here, so we put 2 here, we put 4 here, so that this one now becomes hydrogen here. They are put 2 here to remove this odd number here, 1, make it 2, and then this one is 8 plus 2, which is 5. And that one is now balanced. You liquid, gas, and this one is a gas. Explain one disadvantage of continued use of items made of compound formed by step 3. Compounds formed by step 3, we go back to step 3 and check which compounds are that. So step 3, these are, you can see these are polymers. So it is a polymer. If it is a polymer, what disadvantage do you know about polymers? polymers has got one main disadvantage. It is that they pollute the environment because they are they don't decompose. So they don't decompose. They are non-biodegradable. So you just write that environmental, they cause environmental pollution. They cause environmental pollution because the items are non-biodegradable. Non-biodegradable, in other words, is that these items, they don't decompose. Therefore, they cause environmental pollution. Another sure bet question we want to look at is electrochemistry. Electrochemistry question will not miss in any chemistry exam. So electrochemistry. Electrochemistry. We need to look at questions in electrochemistry. Look at this question. Use the standard electrode potential for element A to F given below to answer the questions that follow. Elements do not represent the actual symbols of elements. Now you see A plus, this is equation like this. You can look at these equations. Now I want to tell you one thing, that the most positive and the most negative will produce the highest EMF. So when you look at this element F and element A, because the most negative is A, the most positive is F, this one, when you combine them, they will give you the highest EMF. When you see C is 0, 0, and that one is our reference, and that one we know our reference electrode is hydrogen. And then you need to know that the more the negative, the more the reducing agent. The electrode potential with the higher negative value is more reducing power. It is more reactive. Therefore, it will give electrons. The more the positive an element is, the more the oxidizing agent it is. The more the oxidizer it is, the less willing to give electrons. So it will undergo reduction. Which element is likely to be hydrogen? Give reason for your answer. The element that is likely to be hydrogen is C2. Why? The reason, hydrogen, we know that hydrogen is a reference electrode. Is a reference electrode whose E standard value is 0.00 voltage. So we know that. So whenever you see the one which is 0.00 volts, then it tells you that one is hydrogen and it is the standard electrode potential. Which is the E standard value of the strongest reducing agent? The strongest reducing agent, I have told you, it is the one with the most negative. So you can see the most negative, there one E, so that is negative 2.90 V. That is the most reducing agent, right? In the space provided, draw a label diagram to obtain C, when B and D combine. B and D combine. Now we have been told B and D. Now look at B. B is negative 2.38. D is positive 0. So it means when we are going to draw, B is going to give electrons, D is going to receive electrons. So you draw electrode, you put the electrode into and then you remember to draw the salt bridge. You draw the salt bridge, and then you draw the electrode in this side. Then you remember to draw the voltmeter here. Once you have drawn that, the most important thing is to tell us what is inside here and which one is going to be B, which one is S. And the name this one is the salt bridge. So if I say that this one is B, then the solution inside here should be P positive, the ions of that. And if that means this one is going to be D, and the solution here should be D positive. The electron should be moving from where to where? From B to D, because B is more reactive. It is going to give it is the one that is going to give electrons, and this diagram is completely perfect for you to get 3 marks. The next question is to calculate the EMF for the cell above. So this one is EMF is equal to E standard of reduction minus E standard oxidation. We have said which one will undergo oxidation. B will undergo oxidation, D will undergo reduction. So you go and write the E for reduction was positive 0.34 minus into minus. That one for this one was negative 2.38. So this one is the same as 0.34 plus 2.38, and that one will give us 0.272 volts, and that is the EMF for this cell. During electrolysis, 2 amperes were passed through. Write the equation for so we are reacting copper 2 here. So the most important thing is the copper ion. So copper 2, which is in a solution, we add 2 electrons, it will lose this one to form copper metal. So that is the equation that you need to know how to write. Because it is in a solution, it is in an ions form. So this one is aqueous. It will lose 2 electrons to form, it will regain 2 electrons to form this one. So it will undergo what we call, this is reduction. It will regain 2 electrons to form copper. Determine the mass and the anode, the mass at the anode. But we know before we go, we must get the quantity of electricity will be equal to I times time. I represent the current, so the current is 0.2 times time, which is 5. We times 60 to make it to minutes. When calculating this one, time must be in seconds. Time is a must to be seconds. So when you multiply this, you get 3600 coulombs. When you multiply that, you are going to get 36 coulombs. But we know that 1 Fahrenheit is equal to 96,500. But copper, it has 2 Fahrenheit. The charge is 2, so it means it has 2 Fahrenheit. 2 Fahrenheit will be what? 2 Fahrenheit will be 193. This times this, it will be 193.00 coulombs. So 193 coulombs has a mass of 63, because that's 1 mole, which is equal to 63.5 grams. So we will ask, what about 36 coulombs. How many grams will it be? So you multiply, so that is 36 times 63.5 divided by 193, and this one will give us a mass of 1.18 grams. Represent part of a periodic table, study it and answer the questions that follow. Let us do not represent the symbols of the actual element. So whenever you have this grid here, you need to know how to label this one from number 1 to, so it means you must have the first 20 elements overhead. So you should know that this one is hydrogen, that's number 1, number 2, number 3, 4, 20. So these are the first 20 elements. So you are asked what name is given to the group of elements to which C and F belong. So C and F is here. This is C and this is F. So you can see that this is group 2 elements. So group 2 elements, this is group 2. So what name are they given? These are called alkaline. So the name is alkaline earth metals. These are called alkaline earth metals. Don't write alkali because alkali metals is group 1. So group 7 here, this is 1, 2, 3, 4, 5, 6, 7 here. Group 7 here, they are called halogens. They are halogens. So those are the things you need to know in the periodic table. And then remember that this is 1, 2, 3. This is period 1, period 2, period 3, period 4. Which letter represents the elements that is least reactive? Least reactive. The element which represents the least reactive is A. Why? Because A is in group 8. And we know that elements in group 8, they don't react because they are stable. They have electron configuration rate of 2 or 2 to 8 or 2 to 8, 8. So they are stable, they don't react. So it means that the answer here is A. But they forgot to write you explain, because you need to explain why you are telling us. You say that because the element do not gain nor lose electrons. In other words, you can say the element is stable. Electronic configuration of that element is stable, so it doesn't react. As simple as that. What type of bond formed between B and E? So you go back and look at B and E, the bond between B and E. So B is here, B is carbon, and then you can see that B is carbon and E is, this is number 16, that is sulfur. That is sulfur. So it is a reaction between carbon plus sulfur. These both of them, they are nanometals, so it's going to form CS. So what bond is between them? Both of them are nanometals, therefore they are going to form covalent bonds. They are going to form covalent bond. Because both of them are nanometals, therefore the bond is covalent. If the bond is covalent, you need to explain why. Because they are sharing of electrons. So you say they form, the reason is that they form bonds. They form bonds by sharing by sharing of electrons. They form bonds by sharing electrons, and that is it. Write the formula for the compound formed when D and oxygen react. So you go back to D, you check which one is D. Which one is D? Let us go back to the table. D is number 13, and that number 13 is aluminium. Number 13 is aluminium. So aluminium, when it reacts with oxygen, they form aluminium oxide. Aluminium has got a valence of 3, oxygen has got a valence of 2. So they interchange, so we will have this one. So they will form aluminium oxide. And then you need to use the letters that were given. Therefore, it is going to form D, which represents aluminium, and then oxygen. So oxygen will put 2 here, and aluminium will put 3. So this is the formula of the compound that is going to be formed. This is the formula of the compound that is formed. On the grid, indicate with a tick the position of element G, which is in the third period of the table, and as G negative. So the charge is -3 and the period 3. So we go there to period 3. Period 3 is here. So this is period 1, period 2, period 3. So we see an element here that forms such a, this aluminum will form positive. So that element must be here, number 15. So because 15 is 2 to 8 to 5, that is phosphorus. What happens during a chemical reaction? It is going to gain 3 electrons to be stable. So it is going to gain 3 electrons to be 2 to 8 to 8. Therefore, if an element gains electrons, it becomes negatively charged. So the element is in period 3 and it is number 15. Therefore, you indicate number 15. The element is here because it was element G. So number 15 here, you write G. So they said you like this. So that's where that element is. Study the information in the table below and answer the questions that follow. Substance H, J, K, L. We have the melting point. Melting point -17, 8, 28, 23 to 19. Boiling point is there. So substance H is very soluble in water, J is very soluble in water, K insoluble in water, L slightly soluble. The density of each of them has been given. This one is the same as this is 0, so it equals 0.077. This one is the same as 0.00133. This is the same as that. So it is important to analyze the table that you have been given. Which substance would dissolve in water and could be separated from solution by fractional distillation. You should know the conditions necessary for separating a substance using. So for these two substances, 1, they must have different boiling points. 2, the boiling point must be close to each other. So now water, we know the boiling point of water is 100, right? So this substance that we are going to dissolve in water and then separate using this formula, this method, it must be close. It must have a temperature that is different but close to 100. So you go to the table and check there. So look at H, it has a boiling point of 78, J -33, K 77, L 188. So the boiling point that is close to that of water is 78.78. Therefore H will dissolve in water because it is soluble. You can see it's soluble in water, and then can be separated by fractional distillation because they have close but different but close boiling points. Therefore, the answer should be H. Reason is that H has a boiling point of 78.5 degrees, which is close to that of water, hence can be separated by fractional distillation. Which substance is a liquid at room temperature, and when mixed with water, two layers would be formed. So 2 layers would be formed. It means it is insoluble. It is insoluble. So therefore K, you can see it is insoluble in water. So definitely this one is going to be K. So the answer is K, because you can see there it is insoluble. So if it does not dissolve in water, then that one is the best answer. It will form 2 layers. So the answer here is K. Reason is that it is insoluble. It is insoluble in water. Next question. Which letter represents a substance that is a gas at room temperature and which can be collected over water method? So a substance which should be collected from Form 1 should be slightly soluble in water. So that is the key word that will help you. So go back to the table and check which substance that is slightly soluble in water. Then when you look at it, you find that L is slightly soluble in water, K is insoluble. The other two are very soluble. Therefore, the correct answer should be L, which is slightly soluble in water, because we know a gas that is collected by over water method should be slightly soluble in water. So therefore, this one gives us the answers. L, slightly soluble in water, because it is slightly soluble in water. Which substance that represent which substance by downward displacement of air, which can be collected by downward? So a substance which is going to be collected by downward displacement of air. Remember, downward displacement of air is upward delivery. Upward delivery. For a gas to be collected by that gas must be lighter than air. So if it is lighter than air, it means it is less dense than air. So let's go to the table and check which gas is there and is lighter than air. We have been given the density of air as this. So you analyze the density of air is 0.00129. So we go back to this one and check which one is less dense than that. So you can see L is 0.013 and that of air was 0.012. So this one is somehow denser. It is denser than air. L is denser than air. K is very dense than air. Look at J. J is 0.07, meaning it is less dense than air. So J is the collected gas that is going to be collected by upward delivery. So here the answer is J. Why? It is less dense than air. It is less dense than air because any gas that is less dense than air is going to be collected by upward delivery. So you can see now the way they combine a question and bring Form 1 work inside. So this is periodic table. It has gone to chemical families. From chemical family they have taken you back to Form 1. So you need to understand this concept from Form 1 to Form 4 in chemistry for you to be able to answer these questions. Okay. welcome. This evening I want to take you through this question. The standard electrode potential for the elements A, B, C, and D given below. You see them to answer the questions that follow. The letters do not represent the actual symbols of elements. So we have this element. You can see the electrode potential is standard electrode or standard electrode potential. For A has negative 0.76, as you can see all of that. Now I want to take you straight to the question so that I can be able to answer this question. Which element is the strongest oxidizing agent? Now that's where I will start to explain something. Strongest oxidizing agent, the most positive is the strongest oxidizing agent. So you just check the standard electrode potential, the one you see having the highest positive, that one is what we call the strongest oxidizing agent. Therefore, in our case, our oxidizing agent is this one. This one is our strongest oxidizing agent. Therefore, how are you going to write? You are going to give this one as element what? D4, because we are going to use this one, the one in aqueous, we give it D4. You can also give D3 positive, because in this case they gave it in forms of the ion. Therefore, the most positive, or if you are confused with this, you can even give the, but they are asking which element, so you give DH. If it is a solid, you give it as a solid, but they have given in aqueous, so you will give it as an aqueous. So the most important thing is to know that the strongest oxidizing agent is the element with the highest positive. The most positive is the strongest oxidizing agent. So if I compare C and D, which one is a stronger oxidizing agent? This one is a stronger oxidizing agent than C, because it is more positive. Next question is, which element is the strongest reducing agent? Strongest reducing agent is the one that has the highest negative. That's what you consider. The highest negative is the strongest reducing agent. As the strongest reducing agent will always give electrons. It will give electrons and it will undergo oxidation. An element which gives electrons or which donates electrons undergoes oxidation. The one that receives electrons undergoes reduction. So the strongest reducing agent here, our strongest reducing agent is element A. As you can see, the most negative. The one that has the highest negative is the strongest reducing agent. The next question is that draw a well-labeled diagram of an electrochemical cell that would be obtained when a half cells of element A and B are obtained. So B and A, we have this one, the one that has negatives. So negative 0.76 and 0.44. So I have, because to save time, so this is what I have drawn. So I want to explain what I have done. This is electrode A. This one is electrode A, and this is electrode B. I have used electrode B on the right side. The solution you are using, the electrolyte, must contain the ions of the electrode. Now this one, you can see this is B, therefore the electrode is B. The electrolyte must contain the ions of B, as you can see. So that's what you must do. It must contain the ions of B. Like they say, similar that, and then 1 molar. It is you remember the standard condition of the electrolyte, it should be 1 molar. So you should write 1 molar of this solution. This solution should be 1 molar and nothing else. And then you should always remember to use the salt bridge. You should remember to include the salt bridge. And then the next thing is this one, the voltmeter. You can use the voltmeter or the bulb, but it's okay, you use the voltmeter. I have explained that. So the next question maybe you will be asked is to show the electrons flow. Where will electrons flow from to where? You must know that electrons flows from the metal that is more reactive. A more reactive metal, electrons flow from an element that is more reactive to the one that is less reactive. So in this case, electrons will flow from where to where? Let me finish this. So let us check which element between A and B, which one is going to give electrons, which the element that gives electrons undergoes oxidation. And you should know that the element that is the most negative, you compare between the two metals you have, that are the two half cells, which one has the electrode standard that is more negative. The one that is more negative is the one that will give electrons. Therefore, A will give electrons. So if A is giving electrons, it means that it is more reactive than B. So B will not give electrons. Instead, it will receive because it is less reactive compared to A. So A is a stronger reducing agent than B, right? But if I compare B and C, B is a more reducing agent than C. You should know. Suppose I gave you the C and the D. Which one is a reducing agent between this? Let me show you this one. B1. If I give you this, which one is a more reducing agent between C and D? A more reducing agent. You should consider, always remember that the most positive is a strong oxidizing agent. So the one that is more positive will receive electrons. The one that is less positive will give electrons. That is something you must always remember. So we were talking about this here. So meaning that A is more reactive, therefore electrons will flow from going from A to B, this direction. The electrons will flow this direction. So electrons will flow from A to B because A is more reactive than B. The next question is calculate the EMF or the E value of electrochemical cell constructed when B, this one is connected. When B and the A is connected, the two are half cells. What will be the, so I have given this here. The EMF is equal, you should know this formula, that the EMF is equal to E standard of reduction minus E standard of oxidation. So it means that you must know which element that is undergoing oxidation and which one is undergoing reduction. That's something you must know. Therefore here, you go back A and B. Which one is undergoing oxidation? Oxidation is A because it is more reactive. It has the more negative. It is the most reducing agent. A most reducing agent will provide electrons, will give electrons. Therefore, A will undergo oxidation. Once you have known that, it is obvious that the other one will undergo reduction. Therefore, 0, negative 0.4 minus according to the formula, and then open bracket because the other one is negative. So you write like that, and then the answer will be that one. You just now, this one, a negative times a negative will be a plus, and a negative 0.44 plus this one will give you positive. This one must be a positive, 0.32 volts. Which two elements, if used together in a cell, would produce the largest EMF? The element that will produce the largest EMF, one that is the most negative and the most positive. I've said that the elements that will give the most the highest EMF is the most negative and the most positive. So if we connect D, element D and element A, it will give us the highest EMF. Therefore, you should know that. You should know that D, this cell, and the other cell, I said A, will give the highest standard electrode potential. So what I have said, the concept is that the most positive and the most negative, when they are combined, they will give you the highest EMF, the largest electromotive force.
So let us question. In an electrolysis, a current of 200 amperes was passed through a molten oxide of metal Q for 58 minutes, and 64.8 grams of the metal deposited. Determine the charge on the metal. 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 So first, we know how to calculate the quantity of electricity. Quantity of electricity is equal to current times time. This time must be in seconds. Time must always be in seconds. But as you can see, our time given in what? In minutes. So you must multiply times 60 to make it so. We have multiplied here times 60 to ensure that we have changed the time into seconds. So time, it is time T times current I. So therefore current is 200, time is 58. We have multiplied by 60 to convert to seconds, to convert this minutes to seconds. Therefore, when you multiply this one, it will give you 696,000 coulombs. The SI unit of quantity is coulombs. But we were given that the metal that was deposited, the mass is 64.8. It means that these coulombs here, this quantity of electricity produced 64.8 grams. So these grams produced this kind of quantity. We will ask, what will the RAM of the Q? Because in here, down here, you will be given the RAM. You must be given that. I think that the question is gone somewhere. Q, you must be given that Q equal to 27. 27. EQ is 27. If EQ it means the RAM of Q is 27. So if this will give you this, what about 27 grams? 27 grams will give us this coulombs. It will give us that coulombs. 27 will give us 290,000 coulombs. But we know that 1 Faraday equal to 996,500. This one is always given in a bracket. That it was given here, but this question I don't know where it is here also. But 1 Faraday here is equal to 96,500 coulombs. That one you was given. If 1 Faraday is equal to this, we want to find out how many Faradays are there in 290. So we find that there are 3 Faradays, and therefore that is the charge of the metal Q. That's how you calculate the charge from the quantity of electricity. I want to take you very fast another question. During purification of copper by electrolysis, 1.48 grams of copper were deposited. When a current was passed through aqueous copper to sulfate for 2.5 hours, calculate the amount of current. Now here we are required to calculate the current. We don't have current, but we know our metal is copper. Copper has how many Faradays? It has 2 Faradays. How do you know? The charge of the metal is the Faraday, is 1 Faraday. If it is sodium, it has 1 Faraday. Copper, the charge of copper is 2. The valence actually. The valence of copper is 2, therefore it has 2 Faradays. So first we know that 1 Faraday is 96,500 coulombs. So we will ask, what about 2 coulombs? What about 2 Faradays? So 2 Faraday will give us 193,000 coulombs. That's what it will give us. But we know that 1 mole of copper ion, or 1 mole of copper is, we have been given the RFM, which is 63.5. 63.5 is 1 mole of copper. Therefore, 1 mole, which is 63.5 grams of copper, has these coulombs, 193 coulombs. So we will ask this amount
the mass that was deposited, what could it contain? What does it contain? How many coulombs does it? The quantity of heat that was produced or that was used to produce this? What is that quantity of heat? So we will ask 1.4 grams will be what? So when you cross multiply, you realize that it will give us 4,498.2678 coulombs. Now, since we have the coulombs, we know the formula of calculating the current, the quantity of electricity. Quantity of electricity, Q equal to current times time. But we have the quantity of electricity now. We have the quantity of electricity, but we don't have current. But we have time. Time, it was 2.5. 2.5 is the same as 2.5 hours. So you must convert these hours to minutes and then to seconds. How do you do that? You know that 1 hour is equal to 3,600 seconds. So you just multiply with 300 and you are done. Because you convert the 3,600 is 60 times 60. You convert this to seconds by multiplication of that. So we have 900 I, and if you divide by that, you will find that our I is, that is current is 0.5. Our current is 0.5 amperes.
Next one, let us go to question, which is organic chem. So where do you begin at such a kind of question? Where do you begin? It is important. I hope you have read, you know these things. Now you will be able to know that this here is a double bond. If it is a double bond, sometimes it is equal sign is not there. They can remove it like that. So you are supposed to know that this one, how do you know? You must know that this one is an alkene. So it is important for you to know that. It is important for you to know that. But to make things easy for you, the double bond is always there. So this one is an alkene. And how many carbons are there? There are 1, 2, 3. So that one is propene. So you should know that. Now we have this. So we have the arrow from propene going up. There is this arrow going up. There is this arrow going up. So we are going from propene to J. What is happening? Step 1. Step 1, you can see step 1. We are adding hydrogen in the presence of the nickel catalyst. That one is obviously hydrogenation. So I hope you should know that once you have seen that, you should know that that is hydrogenation, addition of hydrogen. So when you add hydrogen to an alkene, you form an alkane. Therefore, definitely J is an alkane. And what is the name of that alkane? From here, alkene, this is propene. So we are going to have propane. So J is propane. And you should know how to write those equations. Now from J, we are going to where? We are going to step 2, this direction. So here, we can see chlorine here. We can see chlorine. So we are adding chlorine. You can see that this is chlorine we are adding. And remember, this is an alkane. Alkanes are saturated. Alkanes are what? Saturated. So if they are saturated, it means they don't undergo other reactions other than substitution. So this reaction in step 3 is a substitution reaction. The conditions required for substitution reaction is the presence of the UV light. UV light is required for substitution to occur. Now from propene, when we go to this direction, we are adding bromine. So bromine you have been given here. So sometimes you cannot be, so when you are told bromine, you should know bromine is Br2. So we are forming a substance M. So bromine, when you add bromine to propene, the double bond breaks and it is going to form 1,
2-dibromopropane. 1,2-dibromopropane. Now let us go down from propane downwards. Step Phi, we can see this is a polymer. This one is a polymer. Therefore, step Phi, it is polymerization, right? But it is not just polymerization, but it is called addition polymerization. So we are forming a polymer. What is the name of this polymer? You should know that we are coming from propene. Therefore, this one is called polypropene. Polypropene. Now, I hope we have finished talking about this side. Let us go to this from here, step 3. So step 3 is coming from here, this direction. Step 3 is coming from here, from ethanol. No, is it ethanol? No. Why is it? It is not going to be ethanol because it is how many carbons? 1, 2, 3. Therefore, it is propanol. Right? It is propanol. You count the number of carbon atoms, and you see this is what? This is OH. So OH, it stands for an alcohol. So an alcohol, it is from this alcohol we obtained propene. Which process is that? So removing of water from ethanol to form propene, the process is dehydration. Removing of water is called dehydration. What are the conditions necessary for dehydration? You should know that we must have concentrated sulfuric acid, sulfuric 6 acid, and the temperature of 60, and the temperature of 160 to 180 for that process to occur. Now let us go from propanol down, this arrow, from propanol down. From propanol down here, we are having T and gas P. So what has happened? We are adding sodium. We are adding sodium metal. When sodium reacts with an alcohol, we form an organic salt plus hydrogen gas. Therefore, gas B is hydrogen gas. And then T, it is sodium 1,2,3 propoxide. This one is going to form sodium propoxide. Therefore, T is sodium propoxide. Sodium propoxide. If it is ethanol, we form sodium ethoxide. If it is pentanol, we form sodium pentoxide. So that's how we use that. Now let us go upwards. From propanol up, it undergoes a certain process and water is formed. That is obviously combustion, burning. When ethanol, an organic compound, is burnt, we form water and carbon 4 oxide. So L is actually carbon 4 oxide. So we form carbon 4 oxide, which is L. Carbon 4 oxide. Now we have remained with this coming down here. This is they forgot to write the step. Could it be step 7, all of that? So we are forming Q, and we are adding what? We are adding acidified potassium dichromate. Acidified potassium dichromate is what? Is an oxidizing agent. So propanol is undergoing oxidation to form Q. So oxidation, remember, is an addition of oxygen. Therefore, propanol will added it. If you add oxygen here, you form propanoic acid. So Q is actually a propanoic acid. Q is called propanoic acid. Propanoic acid. It's called propanoic acid. What else have I not? We have not said. Yeah, so we have mentioned all those. So when you come to questions, now you realize that we have answered everything. Name substance J and draw the structure. So substance J is propane. The structure, you know, it is 3 carbons and then hydrogen, 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 like that. Reagent conditioning, step 2. Reagent is concentrated sulfuric acid. We need a temperature of 160. So you temperature of 160 to 108. That's all you should know. That step 2 is
substitution, we need UV light, instead required or sunlight. L is carbon dioxide, B is hydrogen, Q is propanonic acid, M is 1,2-dibromopropane. So simple.
Now let us look at this question. The setup below was used to carry out electrolysis of magnesium sulfate solution using inert electrodes. So we have, you can see the setup, the diagram. So I am doing this so that we can look at the electrolyte. The electrolyte is magnesium sulfate solution. This electrolyte here is magnesium sulfate. So first you must know the ions present in that electrolyte. So here in magnesium sulfate we have magnesium ion, we have this magnesium ion, we have hydrogen ions from water, right? We have hydroxide ions from water, and then we have the sulfate ions from the sulfur, so the magnesium sulfate, right? So the hydroxide ions are negatively charged, as you can see. The sulfate ions are negatively charged. The magnesium is positively charged and the hydrogen are positively charged. So we have 2 cations and 2 anions. Now during electrolysis, what happens when the switch is switched on, or when the switch is complete, when the circuit is complete, what happens? The positively charged ions and the positively charged electrons migrate and they move towards the negative, the cathode. Now before even we go there, which one is the cathode in this diagram? So look at this one. We have been given this, the small one and the bigger one. Yes, you should know the small and the bigger one. Which one is the cathode and which one is the anode? Now the bigger, the one with the long stick is the positive, therefore it is the cathode, the anode. The small is the cathode. When you are given that, you will be able to know that this now is this, let me draw this, this one. This one is what? Is the cathode, and this one is the anode. The one with the big one is the biggest stick stands for the anode. Now, what happens during electrolysis? The negatively charged anions migrate and move towards the anode, because the anode is positively charged and the ions here, they are negative, therefore they will move to the anode. The positively charged ions will migrate and move towards the cathode. So when they reach there, there are 2 of them. There is one that is going to be preferentially discharged. So which one is going to be discharged at the anode and which one is going to be discharged at the cathode? I have given the electrode potential for each. This is in volts. It is in volts form. So we have given all of them in volts. Now, because this one you will be given, and you are supposed to use this information to know the electrons, the ions which are going to be discharged at which. So magnesium hydrogen ions will migrate towards the anode, this side, towards this anode. When they reach there, which one is going to be preferentially discharged? So let us look at it. So say it is magnesium. So let me start from the cathode, because I like starting from the anode, where the oxidation is taking place, where where electrons are given. Therefore, I think that one is okay. So let us start at the anode. At the anode, this is the anode. So when hydroxide ions and sulfate ions reach the anode, the hydroxide ions are preferentially discharged and the sulfate ions remain. They are not discharged. Why? So let us look at the the standard electrode potential for hydroxide ions and the sulfate ions. The sulfate ions is positive 2.01. Hydroxide ions is positive 0.4. I told you the most positive is a strong oxidizing agent, and a strong oxidizing agent is very mean. It does not give electrons. So when you compare between the EMF, the E standard, the electrode standard of hydroxide ions, and that of the sulfate ions, you realize that the sulfate ions has the highest positive here. Therefore, it is not going to give electrons. So the one that is going to be discharged, it is the hydroxide ions. Therefore, hydroxide ions are going to be discharged at the anode, giving out 4.
In the oxygen is given out and water is given out. So that's why now you see in this side here we are going to have hydrogen, oxygen here. So here it is oxygen. Here oxygen is going to be produced there. Oxygen here, oxygen O2. And this one we will see it is going to be hydrogen. The volume of hydrogen is 2 moles. That's why the gap here you can see is very big, because we have 2 moles of hydrogen produced, and the oxygen it is 1 mole. So that's why the volume of oxygen here is less and the volume of hydrogen is big, or is more. Now the magnesium ions and the hydrogen ions migrate towards the cathode here, towards the cathode. When they reach here, let us see which one is going to be preferentially discharged. Hydrogen is 0, right? And then magnesium is negative 2.38. So magnesium is very willing to give electrons, but it doesn't want to be given electrons now in this time. So this one is a strong reducing agent. Remember, this one has already the electrons has been given. We need to receive something that's going to receive electrons. Therefore, magnesium will not receive the electrons because it is the most negative here and it gives electrons. Therefore, this one will receive the electrons and it will undergo reduction. Therefore, hydrogen ions here receives the 4 electrons and we form hydrogen gas at the cathode. Sorry, this one is the cathode. At the cathode. At the cathode, hydrogen is produced. So I hope I have said something that may help you. So name the suitable pair of electrode that can be used in the process here. Because it is inert, we were told it is inert. Therefore, we use carbon-carbon or platinum-carbon. It is okay. State and explain the changes of concentration of magnesium sulfate solution in the process as the process proceeds. What will be the concentration? So, the concentration of magnesium sulfate will increase. So, the concentration of magnesium sulfate increase because the hydrogen and the oxygen given off at the electrode reduce the water content. So the water content is reduced, and therefore the concentration of the electrolyte actually is going to increase. I think that's what I wanted to share with you. Thank you.